Welcome, everyone. The event is now live. Scott, please take it away.
Thank you. Yes, my name is Scott Becker. I'm editorial director of Redmond Magazine, and I'm pleased to be moderating our first session as well as welcoming you today to our Enterprise Multi-Cloud Management Summit, brought to you by Cloud Health by VMware. The editorial staff of RedmondMag.com and Virtualization and Cloud Review have worked hard to bring together some of the best independent experts on this topic for this event, so we really hope you're going to enjoy it. Before we start today's event, we do have some announcements. First, we want to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when the replay is available. Generally, that's within the next few days. Each of today's 3 sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you. And during today's 3rd session, we'll be giving away a Surface Pro 7, but you must be present to win, so be sure to stay on for the entire event. Finally, we do have some resources from Cloud Health by VMware. Those are available in the console right now, so please download and check those out. It's because of our sponsor underwriting this content that we can bring you the summit, so we thank them for sponsoring the summit and supporting the community, and we ask you to check out those resources so we can bring you more events like this in the future. So now, on to the first session of today's summit, which is Improving Enterprise Multi-Cloud Performance. And so this session is going to feature Brian Posey. He's a 19-time Microsoft MVP. He's a technical author. He's a freelance writer who's a regular contributor, I should say, a backbone of Redmond Magazine content. He's also a veteran presenter at our summits. And additionally, he's a commercial astronaut candidate. So, Brian, welcome to the call, and please take it away.
Hey, thanks a lot for having me, Scott. I really appreciate it. And hello to everybody out there in the audience, and happy Friday. So let's go ahead and get started. So today I want to talk about multi-cloud performance issues, and there are many. So this is going to be kind of a high-level discussion because there are so many things that I don't want to get into with regard to the really nitty-gritty issues. But my hope for this presentation is that by the end of it, I'll have given you some things that you can take back and use to reevaluate your own multi-cloud architecture and maybe iron out some of those performance issues that you might be having. So as I'm sure we all know, multi-cloud offers a tremendous number of advantages. For one thing, multi-cloud lets you take advantage of best-of-breed solutions. If one particular cloud provider has a better service model than another, you can use the service in that cloud versus a different service in another cloud. It gives you the freedom of picking and choosing. It also gives you the ability to optimize your cost by choosing to run a service or a virtual machine instance or anything else in the cloud where it's most cost-effective to do so. So there are a tremendous number of advantages associated with using multi-cloud. Unfortunately, sometimes performance issues can also creep into the mix and sort of undermine some of those advantages. Now, I'm certainly not suggesting that you shouldn't use multi-cloud. I think multi-cloud is here to stay, and it's something that most organizations should probably be using. What I am saying is that if you are going to do multi-cloud, it's important to look at your multi-cloud architecture from a performance standpoint and consider the performance impact of the decisions that you're making right now. So what do the cloud providers think about multi-cloud? Well, obviously I can't speak for them, but what I will say is that the cloud providers know that multi-cloud is a thing. I would say they probably reluctantly accept that because let's face it, cloud providers bill you based on the services that you use in their cloud. So the more you run in their cloud, the more money they make. So it's clearly in their best interest to have you run as much as possible in their cloud. But they know everybody's using multi-cloud, and they reluctantly accept that. So the reason why I bring that up is just to bring up the point that even though the cloud providers know that multi-cloud is a thing, they don't optimize their services for multi-cloud. Now, this isn't to suggest that the cloud providers are out there somehow penalizing you in the way of performance for operating resources in other clouds. To the best of my knowledge, nobody's doing that. That's not to say it can't happen, but I don't think anybody's doing it. I haven't heard any stories like that. Just to suggest that the cloud providers aren't doing anything to really help you with multi-cloud from a performance standpoint. So it's kind of up to you to optimize your own performance across clouds. So if you are having performance issues in a multi-cloud environment, The key to addressing those issues is to figure out why performance is suffering. As I said at the very beginning, performance can suffer due to any number of underlying causes. And sometimes it might not even necessarily be one cause. You might have several small things working together to lead to a larger performance issue. But in the vast majority of the situations that I've personally seen, the performance problems stem from bottlenecks. So let's talk about bottlenecks a little bit. Now, one of the things that I'm going to do as I talk about bottlenecks and some of the other concepts that I'm going to be bringing up a little bit later on is I want to initially introduce the concept from the standpoint of a standalone PC. Not that these concepts are only relevant to a standalone PC, just that it helps to kind of simplify the topic a little bit rather than bringing in the concept of, say, bottlenecks and then layering on different cloud issues on top of that. Now, in a standalone environment, a bottleneck is often described as the one hardware component that's holding everything else back. For example, if you've got a really fast PC but a slow hard disk, then that slow hard disk is probably going to get in your way of getting the maximum performance benefit from that PC. There's nothing overly complicated about that. The slow component is usually going to be the thing that holds you back. And every computer typically has at least one hardware bottleneck, assuming that all things are equal. There's always going to be that one component that's a little bit slower than anything else in the system. Now, having said that, in a way, this concept that I just presented about the way the bottlenecks work is something of a fallacy, because even though bottlenecks have traditionally been discussed from the standpoint of it being one component that's noticeably slower and that holds back all of your workloads, very often the bottleneck is workload dependent. So you might have a component that acts as a bottleneck on one workload, but your bottleneck might be a different component when you're running a different workload. Let me give you an example. I've got a PC that I built last fall, and it's a fairly high-end system. And recently I was running a project where I had several thousand photographs that were taken by aerial drones. And I was using software to turn those still photographs into 3D imagery that could be brought into a CAD program. So this is something that is extremely CPU intensive. Now, normally, if you're doing a big project on a computer, it's going to be, typically on a standalone machine, it's going to be your hard disk that acts as the bottleneck because often that's the slowest component in the system. And a CPU is almost never the bottleneck. But in this particular case, the CPU ended up being the bottleneck just because that workload was so CPU intensive, but it didn't make very much use of other resources at all. There was nothing going across the network, for example, and the extent of the hard disk activity was mostly just reading the files. Incidentally, it's a little bit off topic, but if you want to see something kind of fascinating, check out my blog on 1105. I wrote a couple of articles related to the way that machine was overheating, and the CPU load was so intense that the back of the machine, it reached like 140 degrees. It was crazy. But at any rate, the point that I wanted to make was that the bottleneck can vary depending on the type of workload. So the bottleneck isn't always going to be the same thing. Now, in a multi-cloud environment, the number one culprit with regard to system bottlenecks is network bandwidth. Again, this isn't to say that it's going to be bandwidth that's holding you back in every situation, but 9 times out of 10, it probably is going to be network bandwidth that's leading to your performance problems. And there's a very simple reason for this. Within a cloud data center, the cloud providers typically use really high-speed connectivity between systems. But when you start crossing clouds, you're going to be using other types of cables that are outside of the cloud data center, and those aren't going to be anywhere near as fast. So let me just give you a really simple illustration from my own environment. Now, I have a lab in my home, and my desktop connections to the switch are 1 gigabit. I've also got some lab servers, and those are connected at 10 gigabits. But having said that, my internet connection is only 600 megabits. Now, granted, that's a fairly fast internet connection, but the point being that my internet connection is significantly slower than the internet connects within my house. So obviously that's a really simple example stemming from home networking, but the same basic concept applies to cloud and multi-cloud environments. Typically you're going to have very high-speed connectivity within the cloud data center, but when you start going outside of that cloud data center, things slow way down. And the slowdowns are often what leads to the performance problems in your multi-cloud environments. So a couple of other things to consider with regard to this concept is that the actual speeds that you see, especially when crossing clouds, are almost never as fast as what the rated speeds are. And there are any number of reasons why this can happen. It can be related to traffic congestion. It can be related to latency caused by the geographic distance between data centers, or any number of other underlying causes. So one of the crazy things about it is that very often you don't end up utilizing the full bandwidth, or you're not allocated the full bandwidth that you're expecting to get. This happens on home networks, but it also happens on cloud networks and the interconnects between the two clouds. So let me give you a quick example. I took these two screen captures that were on the slide at like 10 o'clock on a Saturday night when I thought that network connectivity or internet connectivity within my neighborhood would probably be at a minimum. I mean, granted, I probably had a few neighbors watching Netflix or something like that, but it's not like I took this first thing Monday morning when everybody was just hammering the internet. Now, the interesting thing about this is that the two screen captures on the left and right side of the screen were taken within a couple of minutes of each other. And yet one of these screen captures shows my available bandwidth at 220 megabits, whereas the other one shows it at 407 megabits. So why the discrepancy? Well, these were two different tests, and these tests ended up using websites that were located who knows where in order to measure the speed of the connection. And that geographic distance probably had a big part to do with the discrepancy in speed. But you also have to remember that I wasn't the only one who was using those services, the speed services that is. So competing traffic could have also potentially resulted in the difference in speeds between the two testing sites. Another thing to think about is that very often you're going to see differences between upload bandwidth and download bandwidth. Now, admittedly, this comes into play a lot more often with regard to residential internet connections, but I have seen it happen with business internet connections too. So if you've got a performance issue with the workload you're running in the cloud and you can't seem to figure out what's going on, this may be something to look at. Maybe your data is having a little bit more trouble getting or maybe the outbound data is not running quite as fast as the inbound data. So in this screen capture, for example, you can see on the left, my download speed was 407 megabits, but my upload speed was only 9. And on the right, my download speed was 220 megabits, but my upload speed was only 8. So that's a huge difference. Again, not something that's going to always come into play, but if you've got an inexplicable performance problem, that might be something that's worth looking at. So let's turn the discussion a little bit more away from home networks and start looking at things that are operating within the cloud. One of the best things that you can do to overcome multi-cloud performance problems is just to avoid storing data in one cloud and processing it in another. Now, admittedly, this is something that sometimes you can't get around. Every once in a while, it's going to be impossible to keep the data close to where the data is actually needed. There are any number of business reasons why that might be the case. But if at all possible, you want to avoid reading large chunks of data across a WAN connection between two clouds. That's going to result in performance problems the vast majority of the time. So what do you do in a situation like this if your data is stored in one place but you need to use it somewhere else? Well, one of the best things that you can do is just mirror that data across the two clouds. Now, again, this isn't always going to be an option. Sometimes there are going to be cost concerns that come into play because at that point you're paying for the data that's traversing the two clouds. You're also paying for the storage at each cloud location. So it could be cost prohibitive to mirror large quantities of data. But depending on how much of a performance impact you're seeing by having your data in one place and using it somewhere else, it may be very well justified to go ahead and mirror that data across clouds. So that way, when your workload is ingesting the data, you've got what essentially amounts to a read cache, a local copy of that data that it can use. Another strategy that you can sometimes use to get around performance issues in the cloud is to take advantage of compression. Now, I couldn't find a good screen capture to illustrate this in a cloud environment, so the screen capture that's on the screen comes from Microsoft Hyper-V. But the underlying concept is essentially the same. Hyper-V, which is Microsoft's virtualization platform, has a feature called replication. And what it does is it allows you to create a standby copy of a virtual machine that resides on a separate server. and these virtual machines are kept in sync using asynchronous replication. Now, as you can imagine, depending on what that virtual machine contains and what it's being used for, some of the replication traffic can be quite large. And if you've got a low-speed connection between the primary server and the replica server, you may end up running into issues getting all of that data over to the replica site in a timely manner. So what you can do is you can turn on this compression feature. And what compression does is it shrinks the data footprint so that way you're transmitting less data across the network to the replica server. Now, I'm using Hyper-V as an example, and I'm pretty sure that some of the other virtualization providers like VMware offer similar features, although I'm not quite as familiar with it. But this is absolutely something that you can do in a multi-cloud environment. You can compress data before it gets sent between clouds as a way of reducing the data footprint and thereby allowing that data to be sent more quickly because there's less of it. Another thing that you can do to reduce performance issues in a multi-cloud environment is to set it up so that you don't ever have to perform any sort of cross-cloud authentication. Because remember, just about any workload that you're going to be running in the cloud is going to require permissions and some sort of authentication. And typically that authentication is going to come from a directory service server or a Radius server or something like that. So just make sure that you have replicas of that domain controller or whatever you happen to be using in both clouds. So that way you never have to send authentication traffic across clouds. Now granted, authentication traffic typically isn't huge and it's not going to make that much of a difference. But there are a couple of reasons why I suggest having replica domain controllers or authentication servers, whatever you happen to be using, having those in each cloud. One is because if you are able to contain authentication traffic to the cloud that's performing that authentication, then that's less traffic that you're sending across cloud, and that's less traffic that's competing with your other traffic that needs to traverse the cloud. So you're freeing up a little bit of bandwidth that way. The other thing is that if you were to have a momentary disconnection between the clouds, you don't want that authentication to suffer and end up causing other problems. So something else to think about with regard to performance in a multi-cloud environment is that even though bandwidth is very often the thing that leads to performance problems, it's not the only thing that can cause performance issues in a multi-cloud environment. Think about virtual machine instances running in the cloud, for example. Typically, when you set up a virtual machine instance, and this holds true whether you're using the Amazon cloud, the Microsoft cloud, or whatever, you have the option of selecting the underlying hardware that's going to be used to host that virtual machine instance. Let me show you what this looks like. So what you can see here is a screen capture that's taken from AWS, the Amazon cloud. And this is a screen that's displayed when you set up a virtual machine instance. It's the second step of the process, and it asks you to choose the hardware that the virtual machine is going to be running on. So what you would normally do is go through the screen, and you would pick hardware based on how many virtual CPUs you are going to need, how much memory you want to be allocated to your virtual machine instance that you're creating, and that sort of thing. And the selection that you make on the screen determines your price, but it also determines the level of performance that you're going to see. Now, the reason why I bring this up is that typically when a vendor creates an application, they will give you some sort of hardware recommendations for running that application. And those hardware recommendations don't change just because you're running the application on a virtual machine or in the cloud or whatever. Regardless of where the workload is being run, you have to make sure that adequate hardware resources are being allocated to that workload. And this is where that screen comes in. This is what gives you the ability to make sure that your workload is receiving the memory and the CPU resources and things like that that it's going to need in order to run efficiently. So if you've got virtual machine instances that are suffering from poor performance, it's very possible that that performance issue is stemming from resources in other clouds that virtual machine instance is reaching out to. But it's equally possible that the performance issues are creeping in simply because inadequate hardware resources have been allocated to the instance in an effort to save a few dollars. So just something you may want to look at. So the bottom line from that slide is to remember that even though inadequate network bandwidth between clouds very often leads to performance problems, it isn't the only thing. All of the bandwidth in the world isn't going to matter if your workloads are suffering from resource deprivation, such as inadequate CPU resources, not enough memory, not enough storage IOPS, or something like that. Sometimes even the storage itself can act as a bottleneck. So I wanted to show you a quick example of something like that. The screen capture that you see right here was taken from a free utility called Land Speed Test. And this is a freeware module. It's something that you can go out on the internet and download yourself and play around with. And what it does is it assesses the performance of your network. Now, as you recall earlier, I mentioned that the connectivity between my desktop and my network switch is 1 gigabit. From there, the connection between that switch and the server is running at 10 gigabits. And then I've also got a multi-gigabit connection out to storage. But if you take a look at the screen capture, you can see that the performance that was measured, and this is internal to my network, this isn't reaching out across the internet, but the performance that was measured was only about 407 megabits. I'm not reaching the full gigabit by any stretch of the imagination here. So what's going on? Well, just to look at a screen like this, there are a couple of different things that could be going on. One of the possibilities is that storage is becoming a bottleneck. If you look at the arrow on the bottom of this slide, you can see that it's pointing to something that says folder and then // So the way that this particular test works is it's not just measuring network performance, it's measuring the ability to go out and write data to a particular network share and then read that data from that share. So you're measuring network bandwidth, but you're also measuring storage performance, and the UN megabits that you're getting as a result is an aggregate based on the overall performance of the network. So all of this is to say that this utility isn't solely information about your network performance. There can be other factors that are leading to value that you see. So what happened in this case? Well, here you can see a breakdown of my network. And again, we're only seeing an average speed of about 407 megabits, which is far slower than any of the connections that you see on this slide. And it's also a lot slower than the native performance of my storage array. So all of the hardware that you see right here is perfectly capable of delivering those higher levels of performance. In this case, the reason why you're seeing that low value that you're seeing is just because of competing traffic. Prior to taking that screenshot, I intentionally set up a couple of other desktops that were running fairly heavy loads and had them reading and writing data to that same storage array, thereby forcing the connection to that array to be shared. And I did this to make a couple of different points. First of all, bottlenecks aren't always tied to bandwidth. They certainly can be, and in a lot of cases they are. And even in this case, bandwidth was the culprit. But imagine how much different things would have been if, say, rather than using a high-performance storage array, I'd just been using a single hard disk, or maybe a share on a desktop PC or something. In a situation like that, performance would have been far worse, and it would have been the storage array rather than the network itself that was driving down performance. So certainly something to think about, especially as you look at those cloud workloads. It's important to make sure that the resources that you deploy in the cloud are sized to match the workloads that you're anticipating having. Second, the situation reflects what can happen as workload spikes encounter. Hey, Scott, if you can hear me, my battery's going dead. I'm going to have to call back in on a different connection.
Okay, yeah, that sounds good. So we'll just hang on. Yeah,
I'll be right back.
Okay, sounds good. Okay. Yeah, so just to sort of recap what we've heard so far, which is really interesting. I'm hearing that we want to first avoid splitting important workloads over different clouds like your database and major applications that use that data. Then replicating the database to the other cloud if you can avoid splitting that data. This is the second big point. And then compressing data was a third important thing. And then just making sure that you're subscribing to the right hardware resources at each cloud provider So really valuable tips so far, and looking forward to Brian's next few points.
Can you hear me?
Issue fixed with the phone? The joys of
VoIP headset.
modern presentation.
Can you hear me?
And just a quick reminder that if you have any questions for Brian, please be sure to put them in there. We've got a few questions already. People are wondering about CSPs, sort of the overall benefits of multi-cloud issues. So looking forward to the Q&A portion as well. And just a quick heads up, back to what we're looking for a little bit later on. In the next hour, we've got best practices for multi-cloud environments. So that'll be Howard Cohen coming up with David Rammel as the moderator. And then we've got a third session on hottest third-party products, moderated by Becky Nagel. And again, quick reminder, that is when the drawing happens for the Surface Pro 7, so don't miss that. And Brian, I don't hear you yet, so you might be on mute. Just got a message from Brian. He's reconnected.
Can you hear me?
Yeah, so be sure to hit that third session, and stick around for that one, and maybe you'll come away.
Can you hear me?
Brian, I still don't hear you. So I don't know if connection's working there. It looks like Brian's going to dial in from a different phone, so we'll just give him another minute. Oh, that's interesting. Okay, we're getting audience feedback that they can hear Brian. Brian, I think you're calling in on the. I think Brian's calling in on one line. Most of us comes in through to the audience. All right, we'll get this straightened out here in a second. Thanks to everybody who's letting us know that you can hear Brian. Appreciate it. I wish that I could hear Brian in the same way that you do. Just the specifics of this particular system. We're actually sort of in a multi-cloud environment here too. We're using two systems simultaneously. Is dialing back in. Thanks to everybody for your patience on this. Appreciate you being here for this hour, and apologize for the and thanks to everybody for all the feedback. Brian, you have a lot of support out there. People can hear you. Thanks to everybody for typing that in. calling back out to Brian too.
Hey, are you there?
Yes. Hey, Brian. Welcome back.
Hey, I'm so sorry about that. You gotta love technology.
Oh,
Within
worries.
the last couple of slides, my phone was making this incessant beeping, and thought it was the warranty department calling for the gazillionth time today or something like that, and it was my battery going dead.
Awesome. All right. Well, welcome back. So go ahead.
Yes. So anyway, before I was interrupted by the dead battery, what I was talking about was that this particular workload that I was showing you had suffered, and one of the reasons why I wanted to show you the way that the performance diminished on this workload was just to show you what can happen when a workload encounters an unexpected demand spike. And this is something that's especially relevant to the cloud, because one of the things that we've always been told about the cloud is that it's really good for being able to scale up workloads on demand to accommodate those spikes that occur. So let's talk about that for a little bit. So let's suppose that you're running a workload in the cloud or even in a multi-cloud environment, and all of a sudden that workload has to accommodate a much larger than usual demand. So what do? Well, your first instinct might be to scale the workload to fix the demand spike. And that's a very reasonable thing to do. It's probably the right thing to do in the vast majority of situations. However, depending on what the underlying cause of the performance issue is, scaling might not always fix the issue. In some situations, scaling might give you a marginal improvement, but you may find that it doesn't give you the level of improvement that you were expecting, because when you scale that workload, depending on how you scale it, what you might actually end up doing is introducing some secondary bottlenecks in the process. So by scaling the workload, you've eliminated the initial bottleneck that was causing the performance issue, but there might be other bottlenecks that are brought in by scaling, so you only see just a slight performance improvement or even a larger performance improvement, but not to the degree that you were expecting by scaling the workload. So how in the world can that happen? Well, let me show you. So in the interest of keeping things simple, we'll go with this diagram that's on the slide. So here we have a web server, and it's connected to a backend database. And this could be within a single cloud. It could be stretched across multiple clouds. For the purposes of this example, it doesn't really matter. The point being that you've got traffic coming into a web server. That web server handles the traffic. It serves the web pages to the people who are visiting the web application. And it sends information to and retrieves information from a backend database on an as-needed basis as a part of its normal operations. So with that said, let's imagine that this web application suddenly received a huge demand spike. What do? Well, again, the normal way of dealing with something like this is to simply scale the application. And what generally happens in a cloud environment when you do that is that you add more web front ends to accommodate the workload. And the reason why this works is because these front ends are typically stateless. In other words, there's no data that's stored on the web server. It's just hosting an application. All of the data resides on that backend database. So now you've got all of these web servers that are typically behind a load balancer of some sort, and they can distribute the incoming data, or the incoming request rather, across the web servers, and they communicate with the backend database, and everybody's happy. All of a sudden, you don't have one web server that's having to accommodate the entire traffic load all by itself. So the problem that you can run into with something like this is that the front-end web server is no longer the bottleneck. Now you've got several web servers, and they're comfortably handling the demand. But in fixing that problem, what you've done is you've increased stress on the backend database, because that backend database that had originally been intended for use with this one web server is now communicating with multiple web servers. Now, again, I know this is kind of a silly example. In a production environment, you're probably not going to be doing things quite that simply, but I'm trying to illustrate a basic concept here. And another important takeaway from this is that you've increased the stress on the backend database, but that database isn't the only thing that you've increased stress on. You may have also increased the stress on your DNS server, on your load balancer. So the point being that there are any number of components that could end up acting as a secondary bottleneck if they haven't been properly scaled to deal with the increased demand in this type of situation. So the last thing that I want to talk about is how you can go out and monitor those cloud resources. In other words, we all know that bottlenecks can and sometimes do occur, and that when a bottleneck is encountered, it can cause performance problems. How do you avoid that? Well, sometimes there's just no getting around it, but one of the best things that you can do is to use monitoring tools to keep up with the workloads that you're running in the cloud and find out how well they're performing and what resources they're consuming. And there are any number of different tools that are available to you. Most of the cloud providers offer native monitoring tools that you can actually use to help find bottlenecks. You can spot applications that aren't really performing quite as well as they should be. And some of these tools are actually quite good. So what you see on this slide is an example of an Amazon tool. This is something that Amazon provides natively. It's called CloudWatch, and it's able to watch your resources within the cloud, collect information, analyze the performance metrics of those applications, and then help you to use that information to make some adjustments that will ultimately result in better performance. And even though I'm illustrating the Amazon tool, all of the major cloud providers offer something like this. If, for example, you're working in a Microsoft Azure environment, there's a tool called Azure Monitor that does something similar. Now, using the cloud-native tools is one approach. There are other approaches. And each of these approaches has its own unique advantages and its own disadvantages. So there are three main approaches. I'll show you what these three are. But in the case of using these cloud-native tools, the main advantage is that this is something that's really cost-effective to do. You don't have to go out and buy a third-party tool. You don't have to take the time to learn how to use that third-party tool. And because it is something that's provided natively by the cloud provider, it's usually got a really nice deep level of insight into the performance of the workloads that are running in the cloud. The disadvantage is that in a multi-cloud environment, you're going to have to use multiple tools if you're relying on the native cloud-provided tools, because the Amazon tool, for example, isn't going to be able to effectively monitor the performance of resources in the Microsoft cloud. Likewise, the Microsoft tool isn't going to be able to go out and gain in-depth analytics into the Amazon cloud. So you're going to have to use multiple tools. Now, these tools do provide you with very good information, but you're not going to have that one single source of the truth. It's going to be up to you to pull together the information that you've gathered from the various clouds, bring all of that information together, and figure out what it all means and where to go from there. So that's kind of the disadvantage to this approach. Now, the second option is to use a unified third-party monitoring tool. In other words, use a tool that's provided by a third-party vendor that's specifically designed for monitoring the performance of workloads running in cloud environments. The advantage to this approach is that if you can find a good tool, then this tool can see across multiple clouds, and it can normalize the information so that you can get a better sense of what's truly going on between the different clouds. Now, of course, there are some disadvantages too. One disadvantage is that it can be expensive. Typically, when it comes to tools in the enterprise, you get what you pay for. So there may be some fairly steep licensing cost. Another disadvantage is that you might find that the tool has a steep learning curve or that it doesn't integrate with the cloud resources all that easily. Sometimes you have to jump through quite a few hoops to get different tools to work the way that you think that they should in a cloud environment. This can be especially true if you have a lot of security mechanisms put into place that might get in the way of a monitoring tool being able to access the resources that it needs. One more disadvantage to think of is that the depth that these monitoring tools from third parties can go into in a cloud environment is really going to vary. And there's a reason for that, because the vendors who make these types of tools are dependent on the APIs that are given to them by the cloud providers. So if a cloud provider doesn't provide access to a particular resource through an API, there's a good chance that a tool's not going to be able to go in and look at that resource with any sort of depth at all. So typically the cloud providers are really good about providing APIs for their various services, but they don't give insight to everything. They hold some things back. Some of that is done for security reasons. Some of it's probably done for reasons of establishing a competitive advantage against other cloud providers. But whatever the reason, there's a really good chance that you're probably going to gain more depth using the native tools than you would be able to get from a third-party tool. That's by no means an absolute rule, but it's just kind of a general rule of thumb. So the third option is to use what I tend to think of as component monitoring. This is monitoring tools that run inside of the workloads. So if, for example, you have a lot of virtual machines that are running inside a cloud environment, then you might use monitoring tools inside of those virtual machines. For example, if your virtual machines are running Windows, you might use the Windows Performance Monitor to find out how that virtual machine is really performing. Like the other methods that I described, this one has its advantages and its disadvantages. One big advantage is that this approach is essentially free. You're not having to go out and license another monitoring tool. You're using something that's native to the operating system. And incidentally, we're not just talking about operating systems here. There are other services that come with their own monitoring tools aside from operating systems. We'll use operating systems as an example. So the tool is essentially free. Another advantage is that it's something you may already be very well familiar with. If you've been a Windows admin for years, for example, you probably already know how to use the performance monitor, so it's going to be something that's extremely familiar to you. The big disadvantage is that not every tool that not every workload you're going to be running in the cloud even has such a tool. And even if it does, that tool is going to give you very limited insight. If, for example, you're running the Windows Performance Monitor inside of a virtual machine, you're going to get a really good idea of the way that your workloads inside of that virtual machine are performing. What the tool can't tell you, however, is what's going on in the underlying stack. The monitoring tool probably has no idea that it's running inside of a cloud-based virtual machine. So it might be able to tell you, okay, you're running low on CPU resources, or you don't have enough storage IOPS or something like that, but it can't tell you why. It can't tell you, here's what you need to do to go out on the cloud provider site and make an adjustment to make this problem go away. So you've got a very limited scope of information that's provided by these sorts of tools. So in retrospect, maybe the best approach is to use a combination of the three different approaches that I've talked about. And by doing that, you should be able to gain a very granular picture of what's happening with regard to all of these cloud workloads. So that's going to do it for me. I've kind of rushed through some of this in the interest of time, but I wanted to be sure and leave a little bit of time for questions and answers.
Okay, sounds good, Brian. Like Brian mentioned, we've got some time here for Q&A, so please type those questions in as you have them. But this was really good stuff. So let's start off with, so it sounds like a good rule of thumb is to try to keep a copy of the data close to where it's being used. Is that an accurate statement of like a key takeaway here?
Yeah, absolutely. It's not always going to be able to or be possible to do that in a multi-cloud environment, but anytime that you can keep the data close to where it's being used, that's only going to help your performance. If you think about it, over the last few years, edge computing became a really big thing. And one of the key concepts behind edge computing is keeping the data close to where it's going to be processed.
Right. Yeah, and that's interesting. I mean, it kind of argues against, sort of a best of breed approach. Like, maybe you've got a good application development team, in sort of AWS, and they like to build things there. But you really want the performance of, say, Oracle's making a big push with cloud, and their main differentiator seems to be the performance of the database there. But it's really a lot to consider as far as how much performance do you lose by switching your data, having the application have to access data in another cloud going over that public bandwidth. Are there any rules of thumb as far as how to think about the kind of performance hit that you'll take by switching, or is it all? I mean, I understand it's all very dependent on your workload and various factors, but have you seen any rules of thumb, or do you have any in mind that you think of as far as?
The way that I tend to think of it is that you always have the option of doing some test benchmarking before you commit to running a workload in production, so that's always a good option to use. But aside from that, the way that I tend to think of this is that everything in IT is a trade-off. Sometimes there are trade-offs between cost and performance, or features and performance, features and cost. So it's really just all about striking the right balance for your own organization. I don't know that there's any 100% universally applicable rule that works in every situation. You just really have to think about what's the most important to your own organization, and whether the differences that you gain in terms of performance are worth the extra cost or worth not using a best-of-breed solution. So it all comes down to what's important to you.
Okay, great. Hey, here's a question from Stephen, which is kind of on the same topic. What's the performance penalty of replicating the data? Would it require substantial bandwidth and may compete with transaction traffic?
It can. There are so many variables that go into it because you have to consider how much data you're replicating, but you also have to think about the data's change rate. If you've got a huge amount of data that you're replicating, that data is relatively static, then there's not really going to be much of a penalty at all, unless we're talking about the cost penalty. So the change rate and the amount of available bandwidth are going to be the biggest things that you're going to have to look at in that situation. And again, you may be able to use compression or other WAN optimization technologies in order to decrease the amount of data that actually has to flow across the wire and make that replication just a little bit more practical.
Okay. Chris has a question related to Azure and cost. The question is, with data exfiltration to another cloud being a large cost in Azure, how would you suggest moving data to another cloud if your main cloud environment is Azure? And I assume that's on the same topic where we're talking about, maybe moving a database or replicating a database to be closer to an application server in another cloud.
Yeah, unfortunately, data egress fees are one of those things that's really hard to get around. It could be that you just have to bite the bullet and do it. Depending on how recently the workload was moved to Azure, it could be that you've got a relatively recent copy of the data stored somewhere on site, maybe in a backup, and you might be able to use that copy of the data to go out and seed the replica and then just replicate the differentials off of Azure out to that other cloud once that other cloud has been seeded. It's really going to vary widely depending on your individual situation.
Okay. Next question from Tom. How accurate have you found the cost calculators for converting physical environments to equivalent cloud-based ones?
Honestly, I haven't looked that closely at the cost calculators for that. I do use the cost calculators for other things. And I found them to be more or less on track. There's always going to be a little bit of a variance, but typically, and I'm only going by my own experience here, but a lot of times I've found that they actually overestimate the cost by just a little bit.
Well, that's good news.
Yeah.
Yeah. So here's another question from Paul, and you got into authentication a little bit, but Paul's asking, are CASBs, cloud access security brokers, also considered bottlenecks?
They can be. Any component in your entire infrastructure can theoretically become a bottleneck. The key there is to make sure that you're using a reputable provider that is delivering you the level of performance that you would come to expect. Sometimes saving a few dollars by going with a cut rate provider can come back to bite you later on in terms of performance.
And so we talked a lot about, stretching workloads across clouds. And a question here, does stretching a workload across clouds automatically mean that the workload will perform poorly?
No, definitely not. It really comes down to what the available resources are and to what extent the workload is using those resources. If you've got tons of bandwidth and you've got a cross-cloud application that isn't using hardly any of it, you're not going to really notice any kind of performance difference from if the application was running entirely in one cloud, simply because it's not using all of the available resources. So yeah, stretching an application across clouds isn't necessarily going to result in a performance penalty. Very often it does, but certainly not always.
Okay. And then sort of on a philosophical level, to kind of bring a lot of this together, do the benefits of multi-cloud outweigh the hassles of overcoming performance issues?
I tend to think so. Again, every situation is unique, but the way that I think about it is, multi-cloud is hugely popular, and granted, you're always going to have some organizations that just jump on the bandwagon and do it because everybody else is doing it. I've definitely seen people that have stretched an application across clouds just because, we have to have a multi-cloud strategy. But if you put that aside and just look at the people that are doing things in a serious way, multi-cloud is a big thing. There are some very compelling benefits to using a multi-cloud solution. And I don't think that a lot of these huge companies that invest heavily in their cloud platforms would be doing that if they found that performance was just a total deal breaker for them. They would be quickly bringing everything back into a single cloud, but you don't see them doing that. So I think that in the vast majority of cases, the benefits that you gain from multi-cloud probably outweigh the performance hit that you would get.
Gotcha. And one last question I wanted to ask about, some of the multi-cloud management approaches that you talked about. Are there tools that are sort of in the second category, of unified management tools, that go across, Azure and AWS, that also bring in some of that component level monitoring as well, or is that a category that's not that well fleshed out?
Typically, and I'm obviously not well versed in every single tool out there, but
Sure.
I haven't really seen a whole lot of crossover between the multi-cloud management tools and the component level management tools. Typically, they are separate.
Yeah. Okay. All right. Well, it looks like that's about all the questions that we have time for. But thanks again, Brian. Great stuff. Really appreciate the information and the thoughtful answers to the questions. It's always a pleasure to have you on.
Thanks for having me.
So everybody, everybody stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, which is best practices for multi-cloud environments. Also take a chance to check out those resources on your console provided by Cloud Health by VMware, and we will be right back.
Welcome back to our second session. David, please take it away.
Okay, welcome back, everyone. Thank you for being here. Thank you to our speakers, my fellow moderators, and of course our sponsor, CloudHealth by VMware, for underwriting this summit and allowing us to bring you this great content. My name is David Rammel, Editor-in-Chief of Virtualization and Cloud Review, and I'm here to moderate the second session of our Enterprise Multi-Cloud Management Summit called Best Practices for Multi-Cloud Environments. Our speaker for this session is Howard M. Cohen, technologist, writer, and senior resultant at the Tech Channel Partners Results Group. So let's get started. Howard, please take it away.
Thank you very much, David. Hello, everybody. I'm going to skip, let's see. Okay, this is me. Just a little background here. I've been in the industry for over 40 years now, and I write for and about the industry. And today we're going to talk about cloud. Actually, we're going to talk about clouds, multiple clouds, working together. And the clouds we're most often going to be talking about are Amazon, Google, and Microsoft. Best practices in multi-cloud environments take place in basically three different stages. The first stage is objectives, planning, goal setting. The second stage, operations, running the multi-cloud environment day by day on a continuous basis. And while all of that is going on, somebody has to be sure to be providing oversight, governance, and monitoring and management. So we're going to take a look at each of those and some of the best practices in each, starting with objectives. The very first question you should be asking yourself is why? Why are you implementing multi-cloud? Clearly, because it's cool and the latest thing is not a good reason to go to the trouble and the expense of building a multi-cloud environment. What you really want to do is come up with good reasons, things that multi-cloud can do that you can't do otherwise, and start from there. You want to know, what do you intend to accomplish? What are you going to do? And be sure that you can justify it, because later on, we're going to build a business case for it, and you want to be able to justify everything that goes into building a multi-cloud environment. What are the benefits to the business? How will the business grow? How will the business improve based on what you're doing? One of the foremost values you want to obtain or increase is the agility of your operation. Your ability to move freely, your flexibility, the ability to take on new projects, new capabilities when you need to. Basically, multi-cloud should obviously give you more choices. And of course, when you're choosing between different places to get things from, you can choose best of breed. You can choose the one that you think works best for you. And enjoy having best of breed in everything. Ultimately, what most people are trying to accomplish is building their own software-defined data center to replace their physical data center. They want to get out of the data center business. They don't want to be operating a data center. They don't want to be maintaining the staff to operate a data center. They want to be able to do the actual work and let somebody else worry about keeping the hardware running. So building a software-defined data center is a big part of the reason most people are taking a look at multi-cloud. One of the things that you're going to want to be able to facilitate is DevOps. We'll talk a little bit more at the end, really, about DevOps. But it's an important new development in the culture. More and more people are adopting it, and multi-cloud lends great support to it. The ultimate goal of DevOps is to create continuous improvement through continuous deployment. So you'll be improving and deploying constantly over and over and over again. It's an iterative process. But again, think about the words, continuous improvement, constantly getting better. We'll talk more about that later. Next, you need to determine your requirements. Now, unfortunately, you can't just sit down and write up a big list of requirements because odds are you don't know all of them. You need to begin with a comprehensive inventory. What are all the applications that are running in your environment right now? What are the applications that have been migrated to the multi-cloud environment? Then you need to survey all the lines of business and all the departments that are going to be served. You want to find out from them, what are their requirements? What is it they need? Perhaps what is it they need that they're not getting today that we might be able to get them from a multi-cloud environment? These requirements are very important because ultimately these requirements will drive your architecture. You will build a multi-cloud environment that will accomplish as much of this as is humanly possible. So to get your architecture going, you need a solid, comprehensive list of requirements from the business. Now, the cloud providers themselves, they're also going to have requirements for you, things that you need to do when you're using their services. And they're not necessarily all going to be the same. So you're going to have to figure out how do you manage to each of them and stay within your contract. Each workload and each application you put on is also going to have requirements. Applications have requirements. How much memory do they need? How much storage do they need? What kind of processing? So you need to gather all of these requirements from all of these dimensions of the environment you're building. The big thing, of course, are the applications. Applications determine everything. Your biggest task here is to map each workload to the right cloud service. Now, how do you know which is the right cloud service? And you need to determine which cloud provider is going to serve each application best. Which one can fit to its requirements? Which one has utilities that support it? Now, what services are available? What features are available that this application would benefit from? You also want to look at VM packaging and cost. Virtual machines are sold in a variety of different configurations to correspond to specific needs, either for more data, bigger volume, greater speed. You're going to need to look at the packages that are available to you, configurations that are available to you, and figure out which one corresponds best with the requirements of each application. You're also going to need to find out if any of the applications need application programming interfaces to connect it to other services. Each cloud may have specific APIs that it requires, and you'll need to find out how to obtain those, how to implement those, and how to continuously manage those. Next thing is that you're going to want to see just how many of your applications are cloud native. Cloud native applications are ideal for the cloud because they're very transportable. They can be moved to wherever you need them to be at any given moment in time. You've probably heard about microservices running in containers. It is the new way to develop software. Each microservice has a specific function. It's in a container with all the resources it needs, and that container can travel the cloud to be wherever you need it to be to give you the best possible performance. It's also very resilient. If a container fails, it just gets discarded and a new one to instantiate. So very resilient environment, up and running all the time. Docker is a product for packaging your containers, Kubernetes for orchestrating and scheduling where your containers are going. You'll be seeing those as you move through this, but it's important to determine which of your applications are cloud native and therefore ready to go in your multi-cloud environment. You also want to look at your existing monolithic apps. Monolithic apps are basically all one big block of code. One big block of code that if something goes wrong in there, it brings the whole application down. Not resilient. Not designed for cloud. Possible to run on cloud. Need to configure carefully. But it's possible that this is the time to consider reimagining and redesigning those applications as cloud-native applications running in containers. Okay, now that you know your requirements, now that you have some idea of what applications and workloads you're going to be running, it's time to develop your strategy. Remember, I mentioned before building a business case. If you need to get funding, you're going to have to build a business case. That's how you justify the allocation of funds to build your multi-cloud environment. Even if you've been given the imprimatur to go ahead and build the multi-cloud environment, you still want to write a business case. You want to write a business case because it can serve as your yardstick. As you're going down the road and you're making decisions about where to take your multi-cloud environment, you go back to your business case and you determine whether or not what you want to do fulfills the objectives that you detailed in your business case. Always a good thing to have. You're going to need, obviously, a strategic plan. How are we going to get this all laid out? What's going to happen first? Who's going to do what? Where are things going to be done? What are we going to do on each one of the cloud platforms? A lot of planning to be done. So you need to lay out a strategic plan. Ultimately, this will lead to a services catalog that your users can turn to when they want to find out if a specific service is available in your multi-cloud environment. Documenting this is very helpful to you because it helps you reduce the number of phone calls you get asking you, can I do this on our multi-cloud platform? Provide them with a services catalog, and you avoid those questions. And this is very helpful. Next up, a migration plan. There are a lot of dimensions to the migration plan. What's going to be migrated where? Of course, we've determined already where each application is supposed to go. What are the migration steps required to get from our on-premises existing environment to that particular cloud? Are there any adjustments we have to make in our other cloud instances? What tools are we going to use to migrate from on-prem to the clouds? And then how quickly, and I want to emphasize this, how quickly are we going to migrate to the multi-cloud environment? I say this because all too many people, especially in the early days of cloud, rushed. They wanted to move everything wholesale over to the cloud. Let's go to the cloud. And that enthusiasm hurt them. It hurt them because they didn't take the time and the care to plan properly. They didn't dot all the I's and cross all the T's, if you will. Your migration plan has to lay out what's going to get migrated first. Probably lower impact applications. So you can afford to make mistakes. You can afford to fail. That can be important. And then as you go, you move to more and more vital applications until finally you're fully migrated over to your new software-defined data center. You will ultimately have to develop an orchestration plan, especially if you're supporting cloud-native applications, making sure that even your VMs are where you want them to be. How are you going to position your VMs? What servers are they going to go on? You've ordered up a bunch of different servers configured differently. You want to make sure that each workload goes to the server you've obtained that's best suited for it. So you need an orchestration plan. You're going to need a management plan. How are you going to manage all of this? Again, you want to keep it as tight as it possibly can be. How tight can you really make it? And then ultimately, remember that all of this is built to support data. So you're going to need a governance plan. What are the policies? What are the rules and regulations? What are the contractual obligations we have to the cloud providers? What are the regulatory requirements that we have to the government? All of this fits in under governance. And there will be people who have to be very careful that you're staying within the guidelines, within the rules, and keeping everybody happy, because violations of any of this can cause downtime. all of a sudden something gets shut off. That's the last thing you want, especially in an environment this large and this complex. Just keep in mind, it's a famous old axiom, but it's always worth remembering. A failure to plan is a sure plan to fail. So do the planning, get yourself prepared, have it all laid out, sanity check it over and over again, and you'll be much happier in the long run. Okay, now it's time to architect our solution and determine how we're going to connect, which we're going to connect to, what we're going to order up, what we're going to structure. The first element that I always start with is resilience. The less downtime you encounter, the fewer screaming engines you end up with. You want everybody to be happy in their new environment. And therefore, you have to get ahead of potential anomalies, potential outages, and build a resilient infrastructure that can survive any of them. It is possible to do that in a multi-cloud environment. You've got instant redundancy because you've got more than one cloud platform. So resilience should be something that you can achieve. Of course, there will be times that even the best resilience can't keep up with the calamity that you're in. You're going to need to redefine what you mean by disaster recovery. Yes, you have multiple cloud platforms. You can fail over from one to another. They have multiple data centers. Microsoft alone has something like 450 data centers around the world now. Build that in. If you're a belt and suspenders kind of person, build your own on-prem backup capability if you need to. It's going to have to be pretty large. But very carefully detail what your disaster recovery plan is. Where does everybody go? Who does what? When a disaster occurs, what are the steps each person needs to take? It goes way beyond your data structure. It goes way beyond your cloud infrastructure. It goes to what people do and how people perform in the time of a disaster. You'll also need to develop an understanding of your dependencies. Okay, what are the infrastructure dependencies? What is required to access the different clouds? Some people think when you go cloud, you don't need infrastructure anymore. It's simply not true. If you're going back to an office building, that office building has routers and switches, modems, so that you can all share your internet connections. Some of us refer to that as the plumbing. It's necessary. It's still infrastructure. You still need it. Those of you who are working at home, you've got a small infrastructure in the form of your residential router and your connections back to your devices. What are the application dependencies? If an application is reaching out for services from other applications, what are those applications? How are they contacted? Can the application reach them easily, consistently, and constantly? And then operational dependencies. Who has to do what to enable the next person to do what, to enable the next person to do what? In any great collaborative environment, there are interdependencies between people and what they do. Let's map these out in advance. Let's try to get in front of them so that we can optimize them. And then you want to develop your cloud architecture so that you can avoid cloud sprawl. You may remember server sprawl. Well, here's the cloud version of it. These are uncontrolled proliferation of cloud instances. Basically, people requesting cloud services, failing to release them when they're done. And they just sit out there doing nothing. The only thing they're doing is incurring billing. You have to pay for them as long as they're open. The cloud sprawl can be very, very, very expensive. Anticipate that you'll be using software-defined networking. Now that we can modify the router intelligence, we should. It's the reason that we created software-defined networking, to give us more control over how we communicate across our networks. especially in an environment where you're contacting 3 major data center entities. You want to make sure you have the most resilient, most high efficiency infrastructure possible, and your ability to manage that through software definition is critical. The other thing is software-defined storage. There was a question last hour about how do you decide where to store data. The answer, once you've engaged software-defined storage, is in the cloud. Software-defined storage determines where's the most efficient place to make the first, second, and third copy of each data entity. And often those data entities are broken out into segments to make them more resilient and more difficult to attack. But it can determine where is the cloud data center closest to the user so we can get the fastest possible performance done all automatically. So if you're building multi-cloud and you're concerned about storage, take a look into software-defined storage. You may be pleasantly surprised. Ultimately, our goal is software-defined data center. That's what we're architecting. We want to put everything in there that we need to support every workload, every application, every user, every object in our network. Okay, we finally finished our planning. We have everything architected, documented. We know our requirements. We know our objectives and goals. We've got all of that cataloged. Time now to move into operations. Let's make the thing work. But once we've deployed, once we've provisioned all the necessary services, we need to think about the most important resource available and necessary for building a multi-cloud environment. And that resource is people. The people who run it are still the difference between good and great. You're going to need to build a cloud team. Now, some of these people in this cloud team may come from your existing staff. You may need to upskill those people. You may need to provide them with training in new disciplines. But when you have people who have the potential and know your environment, that's terrific. So look at the possibility of filling some of those necessary spaces with your own people, retrained and upskilled. Otherwise, you're going to be recruiting and finding them, hiring them, and onboarding them. That's a lengthy process. So leave yourself time for it. To me, the more I can use existing staff, there's a few positions that have to be filled by people who are experienced in multi-cloud. Okay. That's the way it balances. Management, by the way, doesn't just mean technology management. Any multi-cloud environment must have its own financial management as well. So much of effectively managing a multi-cloud environment is figuring out the billing plans and the new discount programs and the changes that come along all the time in various different entities. Your schedule of virtual machines, prices may change. You may or may not want to take advantage of that. You may or may not want to reserve future instances of them to take advantage of discounts that are available now. You need a financial expert who can stay on top of all that and help you figure out what's the most cost-efficient way that's still the most technologically efficient way. All of these people need a leader. The cloud team leader needs to be a pretty eclectic person. Now, we talk about service managers in general, and I think we've realized long ago that if you've got a great logistician, you have somebody who can be a great service manager. They don't need to have deep technical knowledge. Here, however, that's not the case. A great cloud team leader needs to be able to understand what the problem is, what it's going to take to solve the problem. They need to know when they're being told something that can't possibly be true. They need to have enough technical acumen to understand the environment and make sound decisions. At the same time, they have to be great logisticians, making sure that everything that needs to be where it needs to be is there when it needs to be there. That's a tough spot to fill. But when you find somebody who really can do it, it's a huge contribution to your multi-cloud environment. You want to think about how you're going to facilitate collaboration, people working together. Any cloud environment lends to this. What collaboration platforms are you going to use? What kind of communications are you going to provide? But I'm also talking about collaboration within the cloud team itself. You're going to have people who are responsible for managing costs. You're going to have people who are responsible for managing storage, others who are responsible for servers, others who are responsible for operating systems. You're going to have different people responsible for each of these. Why not set up one person from each to sit on a council of centers of excellence and share with each other what they've encountered recently, what they've learned recently? What better way to exchange ideas, exchange planning, and learn from each other so you have a better, more fully rounded understanding of the environment you're working in? This promotes the sharing of these best practices better than anything else you can do. More and more companies are talking about their centers of excellence. This is a great way. This is a great best practice to promulgate best practices and continue to amplify them and distribute them throughout the organization. Centers of excellence. Okay, here's the management team for the Starship Enterprise. We're going to talk about management. The ultimate goal of management of a multi-cloud environment is to have it all in a single pane of glass. One console that tells you everything you need to know about your multi-cloud environment. Even from this distance, it sounds ridiculous and impossible to accomplish. I'll say this, we've said that about a lot of other things in the past. And while it may not be possible, I haven't seen it yet, but ultimately my bet is that it will be possible, and we will condense down multi-cloud management so that it can be accomplished in a very, very small footprint of controls. What you need most from that is visibility. You're in the clouds. Everything's cloudy. You need to clear your vision. And you need visibility of everything. First of all, you want to have a unified, logical network. All one entity with all of these components to it. Your monitoring, first and foremost, needs to include costs. You need your financial experts to be able to consult reports that help them evaluate how much your next invoices are going to be. You can't wait for the invoices to arrive. You've got to plan that in advance and stay well out ahead of it because you don't want that surprise. There have been plenty of people in the early days of cloud suddenly got an invoice for hundreds of thousands of dollars. That was a career-changing experience for a lot of them. The last thing you want. Security. Security is usually the top of everybody's list. Certainly it's as close to costs as in importance as anything could be. You want to make sure your security measures are effective. You want to test them frequently. You want to make sure they're applied consistently across the entire environment, managed consistently, monitored, so that you can detect potential threats as early as possible and resolve them or protect against them as soon as possible. Governance. You want to make sure that your governance team can monitor everybody's adherence to all the different rules and regs that they must adhere to. We'll talk more about access later, but you want to see who's accessing your network. They have the availability of a ton of resources. You want to make sure that's under control. And then, of course, consumption. In the earliest days of cloud, we lacked tools to show us how much we were consuming. That's why those people got those huge bills for overages. They couldn't see in process how much they were using. They couldn't see what they were consuming. And instead, they got an invoice after the fact. Get in front of this. Make sure you're constantly monitoring your consumption so you don't get victimized by one of those bad surprises. From a performance standpoint, you'll be constantly using analytics to compare your performance against industry standard performance in the form of benchmarks. There are plenty of them available. You'll find the ones that you trust the most. But you serve yourself best by frequently returning and seeing how you're doing against benchmarks so that you can report your progress to the people who fund your operation. To be able to do that properly, you need to have KPIs, well-defined progress metrics. What are you measuring to demonstrate that you're operating efficiently, cost-efficiently, effectively? What are they? And once you know what they are, let's make sure we can report on them easily and readily. The last thing I'll bring up about management, the one thing you must manage are your vendors. Microsoft, Amazon, Google, other clouds that you may incorporate. Somebody has to manage the vendors. Vendors are constantly changing policies. Some of those policy changes may catch you flat-footed. Don't take that line down. Go talk to that vendor. Explain to them how they make it very difficult for you to manage. Don't be afraid to make a ruckus if you need to get proper, appropriate service. At the same time, you need to keep track of what the vendors are changing. They may be introducing a great new pricing policy that you want to be the first to take advantage of. The better your relationships with your vendors, the sooner you'll have advance notice of what's coming down the pipe and the sooner you can play. This has always been true of literally every vendor we've ever worked with. It's even more important in complex environments like cloud. Each of these clouds, very complex pricing schemes, very complex technologies, very complex points of connection between things. The vendor is an important component of it, and make sure somebody owns the relationship with your vendor. Next up, the concept of standards. We have standards, plenty of them. You want to have significant, well-established, well-documented standards for everything at all possible. Consumption. Understand how you're paying for consumption, wherever you may be consuming it, from whichever cloud you're consuming it from. This will inform your mapping decision. You may change where you put an application because the cost program's changed, or other standards may have changed. The way in which things interact may have changed in one of your cloud environments. Be constantly on the lookout for opportunities to increase efficiency by moving workloads from place to place. That portability is an important part of the reason you go multi-cloud. So don't be afraid of portability. It's a big part of what you're doing. Remember that each of these clouds has its own standards. They also have their own idiosyncrasies, and you need to be aware of those as well and be prepared for it. You need to establish standards that will work across all three, because you're not going to have people learning 3 sets of standards. It's not going to work unless all of your people are genius level. It's very difficult to have people remember what standards is applied where. So you need to try to bring them all together into one standard that will accommodate all. Not the easiest thing in the world, but it's a best practice to develop these and put some time into it. There are frameworks you can use that will help you get started on building these standards and arranging them so that people can use them. Take a look out there and see what frameworks are available for you. Talk to your cloud providers about the frameworks that they can make available. You may have people on staff who are expert at developing frameworks for environments like this. It's always good to start with a template if you possibly can. So take a look out there and take a look for frameworks. All of this, having everything work in the standard fashion, of course, facilitates automation. And as we said earlier, automate, automate, automate. Automate everything. So let's talk a little bit about automation. I mentioned Kubernetes before. Kubernetes will be a very important part of your world as you move to cloud-native applications. The ability to portably move your application wherever it's best suited, wherever it's most needed, is fantastic. It's incredible technology. Take full advantage of it. You need to be able to control sprawl. Have systems that look for it. Have systems that look for idle VMs. VMs that have been idle for more than a day, more than a few hours, and alert you when there are idle VMs. You may have an abandoned or a phantom VM that doesn't need to be there anymore. You can shut it down and stop paying for it. We talk about workflow automation. Obviously, you want the things that go on within your network to be as automatic as possible, so you don't need operators to make everything happen. On the flip side of workflow automation, I just want to kind of relate it to the work from home phenomenon. There are many, many managers and executives who believe that the farmer's shadow is the best fertilizer. Basically that unless they can see all their people and everything that's going on, things aren't as good as they possibly could be. Those people have been very frustrated for the past 15 months. Expect them to continue to be frustrated. But they can use workflow automation to monitor and manage how people handle their tasks. Introduce them to this. Get some support from your departmental and line of business managers by helping them monitor and manage the activities of their people using workflow automation. It's a great way to make friends and a great use of any cloud environment. You also want to be able to optimize and automate workflow onboarding. When a new application has to be added to the network, you should be able to have it automatically evaluated, and if it's determined that it can be easily provisioned and loaded, the automation takes care of it for you. This frees people up. Or it makes the decision that this is going to be too complex, let's just do it manually. And while we're talking about automating, let's talk about automating data management. Data management in the last few years has expanded to include not only the live data that's sitting out there on storage on your network in your clouds, but also the backing up of that data, the preservation of the integrity of that data by making sure there are offline copies of it available should you encounter a disaster. There's been a great effort to unify all of this, to treat data as data and not as live data and backup. This is a great structure. It makes it more apparent when you have instances. So look at automating all of your data management in one platform if at all possible, so you can manage it more closely and more tightly and more visibly than ever before. No discussion would be complete without talking about people. Your users should exist behind a layer of abstraction. For those of you who have read the NIST definition of cloud computing, it talks about a layer of abstraction between the users and the underlying technology. If you're successful, when a user goes to a self-service portal, they're not going to know which of the clouds they got their resources from. They're not going to know if this is being run on Amazon, or if it's being run on Azure, or it's in Google Cloud. They're not going to know because that's abstracted away from them. They don't have to worry about it. They simply have to ask for the resources they need, use those resources, and then release them when they're done. Keep their lives simple so they can stay focused on the work that they're there to do. That's our job. And so the more you can automate that self-service, the more you can make it easy for users to get what they need and then give it back, and then give it back, the better. Once it's automated, you then have the ongoing responsibility of optimizing everything. Where workloads are located. When things change, you may not want them on the platform they started out on. You may want to move them. There's a variety of reasons. Your monitoring will give you the answers that you need to make those decisions. You want to optimize all automation. Improvements come out all the time. You want to make sure that the latest, greatest version, the latest, greatest patches are there. The security patches are there. All of these are attackable systems. So you want to make sure they're protected. You want to automate provisioning. Again, in that self-service environment, when a user decides they need a few terabytes of storage and they request it at the self-service portal, it should just spin up for them. And it should spin up fast. Any delay will be picked up on. Users know when things have slowed down. You don't want them to slow down. So make sure that your provisioning is optimized so it's the same consistent, efficient operation time after time after time. One of our goals, delighted users. Monitoring capacity. Capacity is something that can be over-provisioned. You may have environments in which somebody decides you need 6 terabytes of storage to accommodate this application, and it turns out they're wrong. In very short order, you realize I'm not using more than 2. Well, in the old world of on-prem, you have to just let that extra storage hardware sit there. But you're in the cloud, and you can release those extra resources and not pay for them. Be sure that you optimize your allocation and your provisioning of resources by constantly monitoring capacity and adjusting all of your reservations to match up with your current utilization. Availability is, QoS, quality service, is the bellwether metric that all of us have lived by for a long time. Are you achieving 5 nines? Is every service available 99.999% of the time? You will be surprised to find that at least one of the major cloud providers does not. They guarantee 3 months. And the number of months of additional downtime that spells would surprise you if you hadn't figured it out already. So determine and optimize your availability through whatever means that are available to you. And I talked before about software-defined storage. Optimize your use of storage. Dedupe is a perfect example of ways in which you can optimize your storage. Across 3 different cloud platforms, it's a much bigger challenge. But it is doable. It is possible. And so ultimately, you want to learn how to do it to the best of your ability. Finally, we get to oversight. And if I haven't burned it into your brains yet, the most important thing to make sure you're on top of are your costs. Because when you have multi-cloud, you have multi-costs. This requires constant vigilance. You have to make sure that you're not leaving ghosts out there, phantom VMs that aren't being used. You have to make sure that you have if you have seats for employees that have disappeared or departed the company, that those are canceled and not being paid for anymore. That's a big thing. When people are off-boarded, their licenses need to be off-boarded as well. Otherwise, you're paying for them. Sometimes you hire new people and buy new ones, even though you have old ones available to you. It's crazy. Procurement is a big part of this. The better they can manage your vendors, the better you can control your costs. So your financial people and your procurement people need to work hand in hand, fist in glove, to make sure that you're being as demanding with your vendors as you possibly can be. One of the reasons is taking advantage of loyalty bonuses, volume discounts. They all have them. Sometimes they're based on future reservations. Sometimes they're based on how many of a given service you reserve. Sometimes it's volume. There's all kinds of different programs with all different kinds of rules. Time of day discounts. When you're using particular resources at a specific time of day, you have discounts available to you. This is why your financial people and your procurement people need to work hand in hand with your cloud team leader and your technology experts to make sure that you're taking advantage as much as possible of these vendor loyalty bonuses. The fact is, if you're all with one vendor, well, all of it goes to them, and that probably gets you closer to your loyalty bonuses faster. When you distribute it among three, you've also diluted your volume with each of them. So you need to pay more attention to these because they can significantly reduce your costs. Again, avoid cost overruns. Be constantly on the lookout for people who have failed to release their resources. Next up again, security, right behind costs. Best to use identity and access management for every object on your multi-cloud network. Everything that's there needs to have an identity. It needs to have specific rights available to it, access to specific resources. This is not just for people. It's for data entities, for devices, for every object that exists on your network. And if there's one rule that you should universally obey, it's encryption everywhere. I don't care if the data is in movement. I don't care if it's sitting in storage, perfectly still. Keep it encrypted. Unfortunately, bad actors are attacking data wherever and whenever they can. If it's encrypted, they get garbage. If it's not, make sure that you've established consistent security policies across all the platforms. Again, you don't want users having to remember what the policy is for using Google as opposed to using Azure. You want to have a point at which all of their policies, the provider's policies, come together into yours. Not always easy to do, but viable. Worth the time you invest in making it easier for your users to consistently apply and enforce your policies. Otherwise, your policies are useless. Identify the potential security breaches that you think you're going to be vulnerable to, including breaches of privacy. Not always possible to digitally protect privacy. Requires rules and regulations that people have to follow. So you need to be extra careful, extra vigilant to make sure that you're protecting them every way you can. And to as great an extent as possible, grant access using role-based access control. Instead of giving each individual person, each individual item, a set of access rights, group them into logical groups of people who all have the same rights and the same access. Then, when it comes time to make a change, you're simply changing one and not all. And finally, let's move into governance, risk, and compliance. You know the risks, okay? You need to identify your risks. You need to know what they are. You need to evaluate each one so that you know in advance how much it's going to cost if this happens. And then you have to figure out how you're going to prevent it from happening. So how you're going to mitigate those risks. You want to eliminate cloud resource waste. We've talked about that over and over. Don't waste those cloud resources, release them. You want to avoid over-provisioning, security risks, and what is each data asset worth? You want to avoid the risk of vendor lock-in, being required to use all the services and utilities from one vendor. It's one of the reasons you want multi-cloud, to have choices. Some vendors try to deny that to you. Also, be aware that people are fallible. There's a risk of them being wrong, making a mistake. And especially when you're keeping pace with continuous changes and all these platforms, in the billing for all these platforms, in the technologies for all these platforms, the rules, the regulation. People can make mistakes. Be prepared for that. In terms of compliance, not just regulatory compliance, you have a contract with each provider that requires you to do certain things. If you don't, you can face penalties. They may decide not to continue serving you. Try and imagine re-architecting your multi-cloud environment minus one of the hyperscalers. Not fun. There is regulatory compliance. You have to know what acts you are subject to and what it takes to be in compliance with them. Important to remember that it's not any given product. There is no product that is in and of itself compliant with regulations. Not about the products. It's about your organization. You have to be compliant, meaning that you have to use products that facilitate compliance. You have to adhere to specific standards. You have to operate in specific ways. You have to observe your own practices, processes, and procedures, and adhere to them faithfully. And most important, you have to document all of this. When it comes time for an audit, if you don't have documentation, you have a nightmare. If you have documentation, you should be able to brush it off. No big deal. Which brings us finally to some parting thoughts to kind of take away from this entire presentation. I know I've covered a lot of ground quickly, but hopefully these will give you some things to think about as you move forward into your multi-cloud environment. Number one, do everything gradually, deliberately. Do not rush. Do everything mindfully. Stay focused on what it's going to take to do it. Okay? Rush usually creates mistakes. And when you're working on three major platforms, those mistakes get amplified, multiplied. When you start mapping your workloads, you're going to need to test the alternatives. Maybe it runs better here. You're only going to figure that out by testing. In other words, piloting. Pilot every application wherever you think it'd be best suited and determine which one really is best. Another thing to take away from this is that you need to monitor everything. That's good. But if you don't review it often, it's worthless. So schedule your reviews. Routinize your reviews. Have an agenda for your reviews to make sure you touch all the necessary basics. Have people available to you whose only job is to track all the new developments coming out from all the different cloud providers. They're fast and furious, and if you don't keep up, you're wasting money. As a general rule, and this is not just multi-cloud, it's anywhere, keep asking yourself, am I fulfilling everyone's needs? Am I making everybody happy? There's one thing you can't produce. You can't produce customer satisfaction. Impossible. Not for you to produce. You can produce customer service. You can produce quality service. You can produce service excellence. But only your customer can produce satisfaction with what you're doing. And then hopefully they share it with you. You need to elicit that customer satisfaction from all your users, all your departments, all your lines of business. Always be asking yourself, is everything as optimized as it possibly can be? Or am I missing something? Because the cost efficiencies available when something is truly optimized are tremendous and noticeable and not just a rounding error. So always be looking for new ways to optimize. Your best friend is your healthiest skepticism. Don't believe anything anybody says or anything anybody shows you. Make them prove it. Make them prove it. Make sure that everything's operating the way you think it should be, the way you know it should be. And as I said from the beginning, you want to apply DevOps. You want the people who are developing the applications in your organization to be working hand in hand with the people who are operating your multi-cloud environment so that things are deployed as quickly as possible. Feedback is obtained from your users as quickly as possible, fed back to deployment as quickly as possible so that new versions can come out. If this is iterating and cycling over and over again very quickly, your users are enjoying more improvement more quickly and on a continuous basis. And what could be better? What could possibly be better than continuous improvement? I want to thank you for listening. I know I've covered a lot of ground. If we have a few minutes left, maybe we can entertain some questions, David.
Yes, good stuff, Howard. We do have time for a question or two, so let's just get right into it. First question comes from Stephen, and he's asking about resilience that you talked about. Here's the question. How realistic is multi-cloud in regard to resilience? Is it feasible to quickly move a workload from one cloud to another in response to an outage in one cloud? Is it feasible to run a work cloud across two clouds at the same time, active?
And the answer would be yes. Of course, it's a conditioned yes, conditioned on the idea that you're using microservices and containers, you're using cloud-native software, because quite frankly, that was designed to be portable across the network and across networks. So multi-cloud is simply connected through your network. And it should be able, your application should be able to travel wherever they need to. As far as storage goes, I'll go back to something I mentioned earlier, which is software-defined storage. Software-defined storage puts your data out in segments all across your network. Those segments may exist on the 3 different hyperscaler clouds. They may exist in other cloud locations, but the software itself determines where is the most cost-efficient place to store them, where is the place that's closest to the need for the workload so that you get the best possible performance, and what's the best way to break up the data so that it is as durable and resilient as possible in case any of these sites fail. That's an awful lot, and when you stop to think about it, it's very close to magic. But when you take a look at software-defined storage, it opens the door to being able to do this. And I think software-defined storage and software-defined networking are just natural things to turn to when you're operating in the cloud, in multi-cloud.
Okay, great. Well, that's about all the time we have for questions. Thanks again, Howard, for a great presentation.
Well, thank you, David.
Everyone else, please stay tuned. We're going to take a short break and be back at the top of the hour for our third session, hottest third-party multi-cloud tools, and the giveaway of our Surface Pro 7. We'll be right back.
Welcome back to our third session. Becky, please take it away.
Hi, everyone. This is Becky Nagel. I'm the Vice President of Web here, and I'm so happy to welcome you back to our third and final session of the day, Hottest Third-Party Multi-Cloud Tools. Some quick housekeeping notes before we get started with this third session. First, we want to thank you for attending. We really appreciate you being here. Please be sure to stick around through the end, not only because by being on live, that's when we have the drawing at the end, that's when you'll be eligible just by being here for that Surface Pro 7. So be here live to make sure you're eligible. But also at the very end, when you leave, you're going to have a survey that's going to ask for your opinions on this event. Please take that survey because our editors read every single comment. We look at every survey. They read every single comment, and it helps us plan future events. So please, please, please take that survey, share your honest opinions because your feedback helps us plan these events and future events. So we really appreciate that if you do that. And also, speaking of future events, we really want to thank our sponsor, Cloud Health by VMware. They're sponsoring this event. They underwrite this content, and they're supporting the community by doing this. It allows us to bring you these summits for free. So we thank them. We're honored to be, associated with Cloud Health by VMware, and the Stick Race Company. They put those resources in the console for you. So please download those, show your support, show that you want to have more events underwritten by companies that are of this high caliber and that we appreciate them. So we appreciate them, we thank them, and please show your support and that you want more of these kind of events by downloading those. And thank you to Cloud Health by VMware. We really, really appreciate it. So thank you to our speakers, thank you to our moderators, and again, thank you to all for showing up. And make sure you stay on to the end for our prize drawing. So now, with that, I am so thrilled to be able to announce to you our speakers for this third session. We have with us today Andrew Rice, Sales Engineer, and Carolyn Fay, Account Executive for Cloud Health by VMware. Andrew and Caroline, please take it away.
Hey everyone, my name is Caroline Fay. I'm an account executive over here at Cloud Health, and I'm joined by Andrew Rice.
Hi everyone, I'm a sales engineer here with Cloud Health.
And today we're going to be talking about accelerating digital transformation within the cloud and building out a cloud center of excellence. So our agenda for today, we'll have three main sections to our presentation. First, we're going to talk about public cloud, how it's transformed this past year. Second, we'll be going into building out a cloud center of excellence, why companies need it and why they're moving towards it. And then at the end, we'll cap it off by talking about Cloud Health, who we are, and how we're helping companies transform their business in the public cloud. So looking at the past year and the pandemic and how that's changed public cloud adoption as we've moved through the pandemic, some 5 main areas that we've noticed in trends within our customer base. The first 3 really relate to public cloud spending. First one that we've noticed is that the total cloud spend has increased throughout COVID-19, and they remain higher than pre-COVID levels. So quick stat here, the total cloud spend was 19.3% higher at the end of Q3 than the beginning of Q2 of last year. Compute spending, we've actually noticed that the percentage of monthly cloud budget devoted to compute services actually was lower at the end of the year towards the beginning of 2020. And then also by mid-2020, spending on cloud service providers like committed use pricing, such as savings plans or committed use discounts, increased exponentially over 180% year over year. So customers are looking to adopt the public cloud. They're spending more in the public cloud and moving towards that transformation, and also looking to get those discount pricing options from the public cloud providers. We noticed that even as compute usage declined, that the investment in database storages and services like that grew slightly over the year as well. And I think the most important thing to note here is that the 5th point, being public cloud infrastructure provided very much very, very valuable for organizations. And they need to support new large-scale workloads on a short notice. We noticed a rapid increase in people moving to the public cloud and expanding their workloads in the public cloud as we moved throughout last year. So what does this mean for businesses in this coming year in 2021? First off, cloud financial management is becoming more critical for organizations of all kinds. A lot of companies are looking to see where they can optimize their costs and make sure they're maximizing efficiency while scaling their infrastructure. We've also noticed a rise in container usage and how that can introduce a number of financial management challenges, trying to understand how to label these containers, understanding their cost drivers, and allocating the usage and cost across your cost centers and understanding those costs per container. We've also noticed that in this year, companies are going to have a need to enhance cybersecurity amid the continuation of COVID-19. We've also noticed that organizations ramped cloud usage unexpectedly in 2020, and that they need to ensure that as they move forward and scale their business, that they're ensuring that their operational processes and governance policies are adopted accordingly. Within the past year, there has been an overwhelming need to build out a cloud center of excellence. And for those of you that might not know what that is a cloud center of excellence is a cross-functional working group that's tasked with supporting and governing the execution of any organization's cloud strategy. So to do this, they're collaborating, they're adopting best practices across a range of different disciplines, from operations to finance, engineering, and security. And also they're evaluating and supporting implementation of new and existing cloud technologies. Where Cloud Center of Excellence actually might differ from other centers of excellence, it is more likely to be a long-term entity with a continual collaboration as companies scale and grow in the public cloud. But you're looking at engaging at all levels, looking at best practices and governance, making sure that customer service is centric and at the forefront of what you're doing in the public cloud, making sure that cross-functionally you're aligning on goals and resources, and that as you move throughout your journey, you're observing, you're learning, you're teaching each other and new teams that are using the public cloud. At the end of the day, making sure that you're executing on the best cloud strategy and driving those best practices across your business. So how does Cloud Health help with this? So Cloud Health, our goal is actually to help empower these Cloud Center of Excellences. Cloud Health, our goal is actually to help empower Cloud Center of Excellence and help companies build them out. So what we're doing is helping companies increase their agility, which is by delivering higher quality products and solutions faster while making sure that we're keeping costs and security under control. We're helping improve collaboration by getting different stakeholders access to information so that they can make decisions faster and remove any friction that can come with working cross-functionally. And finally, we're helping companies drive innovation. They can spend less time worrying about what's going on within their public cloud environments and more time innovating and focusing on their core day-to-day tasks. Now I'm going to hand it off to Andrew to talk a little about Cloud Health and how we're helping our customers today.
Thanks, Caroline. Cloud Health is the global leader in multi-cloud management. We are a software solution that over 10,000 businesses use to manage their cloud environments. We work with some of the largest cloud consumers in the world, managing over 11 billion in cloud spend annually across all of the leading public and hybrid cloud providers. We also, recently added support for Oracle Cloud, and we support a variety of container solutions, really supporting, different use cases and different environments that our customers leverage. On average, we're helping our customers achieve about 25% cost savings. We do this not just by providing data and recommendations for optimizing your infrastructure, also by teaching a framework that helps you align your cloud strategy across teams and departments, which is a main theme that we're going to be discussing today. Also, VMware, it's a name that many of you, of course, know, was a Cloud Health customer for many years before ultimately buying us in 2018. So Cloud Health, of course, now is positioned as a leading solution for multi-cloud management across VMware's entire portfolio. So let me walk you through the Cloud Health platform so you can understand how it works. And I find it easiest to kind of review this infographic starting at the bottom. looking at our data model and how we ingest data across the major public cloud providers, looking at AWS, Azure, GCP, Oracle Cloud, as well as VMware Cloud Foundation. We integrate with all of those different environments, pulling in rich metadata, whether that be across your infrastructure services, container management, your platform services. We're pulling in all that data and adding it to our, or essentially providing an integrated data layer. And from here, you can utilize different Cloud Health functionality, such as our Perspective Engine, which provides deep visibility, allowing you to understand different use cases, such as categorizing and viewing your assets according to any logical business group. For example, looking at your costs through a line of business lens, by environment, by application. And you can use these groupings to create and subscribe reports and dashboards, essentially shifting left and sharing that information across the organization, driving, faster decision making and just better overall understanding of, dynamic environments that the public cloud tends to create. In addition to financial management and visualizing and reporting on your data, the Cloud Health platform can also be used to optimize and recommend. So you can receive actionable recommendations to reduce cost, improve security, streamline performance, everything from RI recommendations, flagging security vulnerabilities, untagged infrastructure, or even underutilized assets across all of your public and private clouds. And then kind of tying things together with our automated actions. This would be a way to utilize the Cloud Health platform to actually take action on the recommendations. You can set up guardrails. There's quite a bit to the Cloud Health platform. For a deeper dive into the functionality, we definitely recommend reaching out to our team. We'd be happy to go into further details around each of the different use cases. And we're going to be expanding on some of the core pillars. There's a lot to the Cloud Health platform. Many different use cases, different ways to leverage our technology to drive your public cloud transformation. For the sake of time, we would recommend you reach out to us for a deeper demo. We'd be more than happy to showcase our capabilities specific to your business needs. For the remainder of this presentation, we'll be walking through a few examples of some of our core pillars and how that ties into the Cloud Center of Excellence journey. Now, building a successful Cloud Center of Excellence, we've defined this maturity model that really helps us understand where our customers fit. We work with customers across any different size, any different stage of that journey. We can really help our customers regardless of where they're at in their cloud journey. And the way to kind of look at this maturity curve is looking at the three pillars of successful cloud management, starting with financial management, whether that be trying to understand a cost of goods sold or total cost of ownership, just helping teams understand their trends, be notified and alerted as costs increase. All of that kind of follows the four stages that are depicted along the x-axis, which would be around visibility, optimization, governance and automation, and business integration. And all of this essentially aligns to the three pillars being financial management, operations, and security and compliance. So the main takeaway here is essentially that Cloud Health is here to work with our customers regardless of what stage they're at and help drive them to that next level. So here we're going to dive into some of the core pillars of Cloud Health and how we assist our customers and bring additional value. Starting with visibility, being a multi-cloud platform, we're going to provide deep visibility across each of your cloud environments, as well as a multi-cloud view that can combine and normalize the data so you can understand costs across all clouds rolled up to particular groups, whether that be looking at things by project, as this image depicts, or it could be understanding cost by environment, by cost center. It could be by team. Now, in addition to being able to visualize the reporting and to automate the delivery of reports, we're also helping finance teams perform showback and chargeback, and overall establishing a culture of accountability, which is very important for that Cloud Center of Excellence, and that's one of the key drivers. Next is optimization, and one of the key use cases for optimization is to reduce wasted spending. And to do that, we have a policy engine that helps you to monitor across all of your public and private cloud environments to identify unused or non-compliant resources, right-size existing resources, exchanging convertible reservations, purchasing new reservation discounts. These are just a few examples of the ways that our policy engine can work with the platform to make recommendations and to take action. In addition to just reducing wasted spending, we can also help our customers reduce their overall costs through taking advantage of different discount mechanisms, as well as through right-sizing and improving overall efficiency of your infrastructure. And the third pillar of cloud management is governance and automation. Here, we work with you to create policies to govern your environment, helping you to manage by exception rather than having to, continuously monitor manually. What you do is build the guardrails using all of the data that we're consuming in Cloud Health, and then we can either design alerts via email or Slack, or we can enable automated actions to essentially take that action on your behalf and automate the workflow to save time, as well as to capture savings faster.
If you guys are interested in learning more about where you fall on that cloud maturity curve, we offer a free cloud management maturity assessment. You can take it on our website. As you can see, it's cloudhealthtech.com. We encourage everyone to take it. It takes 15 minutes. It's completely free, and it will give you a good benchmark of where you are in comparison to others within your industry and of same size and footprint to you.
Thank you so much for that presentation, Andrew and Caroline. That was so great. And yes, such a great tool, that assessment. Everyone who can, please go check it out. We do not have time for questions today, but if you put your questions into the console right there, we are going to go ahead and we'll get them over to Andrew and Caroline, so you will get your questions answered. So go ahead, if you have any questions right now, put them in there, and we'll get them over to Andrew and Caroline. We'll get them answered for you. Check out that assessment also, and then check out those resources on your console on the right. So that way we'll get them all for you. So, and then yes, so when people are asking if there's presentations, you're also going to get a copy of all of this. The presentations are on your console. You're going to get a copy of this email to you. So, and anything else that you need, put it in the console right now, and our team is right there. We're going to answer all your questions and or get them over to any of the speakers. So anything else that you feel like you missed, you didn't get today, you need more information on, put it in the console right now. We're here to help you. That's what we're here for. So now I'm absolutely thrilled to be able to announce the winner of our prize. The name is just pulled. So hold on one second. I got to go over here and find it. But the winner of our Surface Pro 7, and the specs were on the site, but it is a nice model, so I'm very happy about that. And it is, what did I do with it here? One second, I apologize, guys. I'm just trying to pull it up. And it is, Olivia, can you send it to me again? Okay, it is Joe Parlett. Yes, Joe Parlett. Joe, you are the winner. So congratulations. You won the Surface Pro 7. So what's going to happen is Olivia or someone else from our team is going to reach out to you directly, and they will get you the information and get in contact with you of how to send that to you. So thank you again, everybody, for being on this call. We really, really appreciate you. Again, thank you so much to our sponsor, Cloud Health by VMware, for allowing us to put on the summit and getting you all this great information for free. Again, please please take that survey when you leave. Let us know what you thought, so that way we can bring you more of these events, because we really enjoy it and we want to bring you more of them. Thank you again to my sponsors and fellow moderators, and have a wonderful day, you guys. We'll see you next time. Thanks. Bye-bye.